right, well, I have 35 past the hour, so we'll go ahead and get started. Welcome. This is AI in Action. This is when robots learn, bringing machine learning into my Introduction to Computer Science class. Um, Make sure I got the right screen here. Okay, this is our agenda. We're going to do a little bit of a welcome, kind of in that right now. I'm going to talk to you about why I use the Finch robot and Teachable Machine from Google. Talk a little bit about Python, the programming language we use in this class, and then how do I transition to machine learning from the Finch robot to machine learning. And then I'm going to talk a little bit about some activities I do around image and voice recognition. And then we'll close it out and hopefully have some time for you all to ask questions if you have any questions. But first, starting off, welcome. My name is Matt Alonzo. I am a tan-skinned male, middle age. I have a beard and hair, full head of hair. It's salt and pepper colored, but to be honest, it's more salt than pepper these days. I have been teaching since 2003, where I started teaching mathematics at the high school level. I am a Impact Fellow from 23-24 cohort, which is cohort 5. And then I am a Responsible AI Fellow, this first inaugural fellowship here this year. So I'm very excited to be able to engage with you this evening and tell you a little bit about what I am doing in my classroom. So why this session? Why even be here? So the goal is to show you what happens when students have an opportunity to see and touch how AI works in the classroom. We want to learn physical, hands-on computing with the Finch robot, and then pair that with machine learning with Google's Teachable Machine, where students can build machine learning models. And then how does that equate into accessible learning for our beginning students, these students in an Introduction to Computer Science class? So let's move into the why teach Finch and the Teachable Machine. So I use the Finch robot in my classroom. If you're not familiar with it, BirdBrain Technologies is the maker of the Finch robot. I've been using it in my classroom for the past 5 years now. This robot is very approachable for students. They can make it move, react. It has sensors, and we code it in the language of Python. So students are learning real coding in kind of like a playful, kind of low-key way. They do have a lot of fun with it. So the Python language is the language we use with the Finch robot. And this is where students are able to start building some strong foundations of computer science. Leading into this, we do some block coding to start them out with, because my students come to me, some have coded before, a lot of students have not coded before. So we do a little bit of block coding leading in this, and then we start really laying down the foundation of text-based coding. And Python is the avenue that we do that. So the Finch becomes the purpose for learning instead of abstract assignments. My students are able to write code and get the Finch to do something. And there's example code right there on the screen. BirdBrain has their own Python-ish language. It's called Brython is what they call it. So one of the activities that I do in my class is I have my students, after they have learned about the sensors that the robot has and how to make the Finch move, and how to get it to react to its environment, my students are tasked with a project. This is the big project in this section, where I built a maze, and there's a picture of it on the screen. I used the corrugated cardboard, kind of like the cardboard that you see like yard signs made out of. And I cut strips of that and I lay it down and tape it down to a mat that I have on the floor. And you can see the maze is very basic. There's no dead ends. It's either the Finch has to go right or has to go left. And so my students are tasked with getting the Finch to think about how to navigate the maze. And the goal is that they move into a space and they ask the finch is able to ask itself a question: do I turn right or do I turn left? And they use the distance sensor to try to establish which direction. So they'll turn to the left and they'll see it's either blocked or it's open. And if it's blocked, they'll turn around and go to the right, or they'll move in that direction to the left. There's a lot of just different approaches that students take to solving this problem. And it really helps to solidify the stuff that they've been learning, which is the the sensors and making the robot move. So this is a really fun, big activity, and my students really love to do this. I have at the end of this a resource, the actual assignment, the guidelines, and everything attached. So if you're wanting to use this in your classroom, you can definitely steal that from me as well. What do students learn? So by the end, students have a deeper understanding of how programming decisions affect the physical behavior in the surroundings. They've also learned how to break complex problems down into manageable problems. So we talk a lot about decomposition and decomposing a problem. So where does this translate into machine learning? So what I found is in teaching this and in students doing this project, they would often make comments like, well, wouldn't it be nice if the robot would just be able to do the maze on its own, think its own way through the maze? I'm like, well, you're kind of doing that. But they're like, no, what if it could see, like with actual eyes, or hear? So, what I do is I have the students think about that just very topic. And we talk a lot about what are some things that we have that we're able to use, where we're able to talk to the machine and stuff like that. So they come up with things like Alexa and Siri and self-driving cars, right? So therefore, what we do is we then transition into teachable machines, right? So sorry. So what we do is we try to remove any intimidation barriers. So students are now thinking about, how do I get my Finch to now think based on an image? So we start with images. So we use Google Teachable Machine. It's very, very easy to use. And even on BirdBrain's website, they have some activities around the machine learning. And what we start with is pictures, and we have pictures of birds. And so I say, okay, we're going to show our computer these bird images. And we're going to teach the computer what bird it is. So it's whether it's a cardinal or an eagle or a finch, or I think an owl is one of them that we use. We're going to have our finch robot, react based on the picture. So we do things like, I showed a picture and the lights will light up. So if you showed a bald eagle, the lights on the finch will light up to red, white, and blue. It's very patriotic and American, right? And so they get that idea. So then what we do is I tell them, okay, what kind of signs or what kind of images would you give your finch robot if you wanted your finch to navigate its way through the maze? And then talking this through, they're like, well, we could do like a stop sign. What if it was able to recognize a stop sign or a go sign or a right arrow or a left arrow? So now my students are thinking, well, how can I show it pictures to tell it where to go on the screen? So a little bit more about the Google Teachable Machine. So it has image recognition, where you give it classes. So you tell it the different classes that you want it to have. You gather as many pictures as you can, or images, and give it to your teachable machine. You train the model, and then you import or export that model and import it into your Python programming. Now, the coolest thing that happens is students then try to do this with their own faces or images. And what they quickly notice is that the images that they receive or images that they import is only as good as the data, right? And so I do this with my students. I say, okay, let's record our faces and let's give some classifications. So the classifications I have are like no expression, happy, sad, and surprised. And one of the things that happens is bias, right? So this leads into a conversation with my students about how AI models like this could be biased. Like here's a picture of a woman who's definitely smiling, but I trained the model with my face and my face alone. And yet it's saying that this woman's sad, right? And so there's definite bias there. Some other things that can happen are inconsistent predictions. Here is another picture of someone smiling, and it says 50%, 45% no expression, or they're happy, or maybe a little bit of sad. So there's some inconsistencies here. Then we show it another picture of someone who's clearly smiling, but yet it comes up with surprised as the way that it is. So this is shows the fragility of poorly collected data. But I will say this: sometimes it nails it. It gets it right, right? Like me and George Clooney, we're one in the same. So it says like, yeah, that's George Clooney smiling. You're both smiling. So you're both happy there. Oops, I forgot to advance the slide. There it is. So yeah, my kids get a real kick out of that too. But it produces a great conversation about bias and how AI, which uses these machine learning models, how it is flawed in those ways as well. So the next task I give my students is now that they've explored with pictures and we've done some activities with pictures, I say, okay, now is your opportunity for you to speak to your Finch and tell your Finch what to do. And so they start learning. You can also do in Google's Teachable Machine voice. So you can give it samples of you saying things. You can even play audio to it as well, and can it train itself on that. So students record voice commands. The model is trained based on their audio. They export it to Python just like before, and then they teach their Finch how to respond to their voice. So they quickly learn to say things like go, stop, right, left. And then they're speaking to the Finch robot. Well, they're not speaking to the Finch itself, they're speaking into their computer, which then talks to the Finch. But their Finch is navigating the maze with their voice. So now my students have been able to program the Finch to navigate the maze based on an algorithm that they've written. They've now been able to navigate the maze based on images that they show the Finch. And now they're navigating the maze through the voice recognition. And this is all made possible through machine learning. So why it works, it's fun. It's low stakes. All my kids get involved with this activity. Everyone wants to do this because it's not difficult, right? The machine learning happens through very accessible Google Teachable Machine. If you have not tried it out, go there, check it out. And it imports the model, and it's easy to load it into your program as well. It transforms something that's very abstract into something that's more concrete, and students then can picture and visualize and experience and feel it. It does give our students a very immediate feedback, and they do gain some ownership in the work that they're doing. So in closing, the things that I have noticed about the classroom impact is I've seen students who are very hesitant about CS. And then once they see stuff like this, like programming the robot, doing machine learning, their engagement level goes up. They start to understand things a little bit differently. It's not magic, if you will. Computer science is not magic. AI is not magic. And they start to understand that. And then they have authentic conversations about bias and authentic conversations about how AI and machine learning really has a bigger effect on their lives and an impact on the environment around them. So I know there's been some questions flowing in the chat. I know I saw something in there about creating the maze. I did create my maze. So I bought some corrugated cardboard from Home Depot, and then I cut strips of it, probably about 3 or 4 inches high. And then what I did was is that you can cut a slot in it and cut a slot in the other piece, and they'll just kind of like fit into place. So that's how I made my maze. I mean, you could probably make your maze out of a lot of different things. You just want to have something that is high enough that the Finch distance sensor will sense when it approaches what is there. Um, but yeah, like other questions. Do you have other questions? Feel free to throw them in the chat. If there's a question that I didn't see, feel free to put it in there now. I'd be happy to answer any questions. Once you have access to the slides, I'm not really sure if you have them right now, but on the resources page, there's a lot of links there. I have my maze project and scoring rubric, which is there. The Finch Python library is there. That's also made available on Bird Brain Technologies website as well. Yeah, I can totally throw that link in the chat for the good call. Let's see. All right, try that link there. Yeah. So that is the presentation that I just dropped in the chat. So any questions? I really do appreciate you all coming tonight and checking this out. This has been an exciting adventure for all of us. Really, I'll be honest with you, my AI journey is I'm in the infancy stages of my AI journey. So it's never too late to start learning about it. That's for sure. Well, you all are very welcome. I know there's another networking event that's coming up here as well. And then after that networking event, there's one more breakout session. And then at 6:30, we're back in the main stage. So thank you all for coming. If you have any questions, I'll put my email in the chat as well. There's my email if you want to grab my email. If you have any questions, any follow-up questions, or if you think of something later on you want to ask me, feel free to email me and I'd be happy to answer any questions that you have. All right. Thanks, everyone. It's great being here with you all tonight. Thank you for coming.